Well, Barry, thanks very much for joining today. I really appreciate you scheduling this live discussion because I think that it may be better for folks versus the classic interview format, because this is a subject that should be interesting to the community here about jobs, which is not something people normally associate with philosophy. And before we start, why don't I just let you introduce yourself and then we'll dive right in.
So I started life as a philosopher working on the phenomenological tradition, the tradition around Brentano, and focusing always on philosophically viewed ontology topics. So the ontology underlying Husserl's logical investigations was the topic of my dissertation, for instance. And so I continued working on ontology, applying ontology. So one of the more important examples of that was applying ontology to geospatial informatics. So how do systems of navigation, for instance, that you have in your car, conceptualize the geographic reality that they have to navigate around? I had some success in that field, and I was cited quite a lot. And as a result of that, I was selected to win one of a series of brain drain or reverse brain drain prizes, which the German government initiated in order to try and entice non-German thinkers to go to Germany to set up new institutes. So I had money to set up a new institute, and I chose the topic of medical ontology. So I didn't know anything about medicine. This was around 2002. But I knew about ontology, and I knew that medicine is full of interesting phenomena. And so I hired people working in medicine. I hired other people working in ontology and brought them together. And in the 4 years during which I was actively engaged with the Institute, we published more than 100 papers, which I think had a big impact. And now the question is why? Why was medical ontology able to have an impact? Well, this was the period when medical scientists were confronted with gigantic new bodies of data, the Human Genome Project data, and all the different kinds of omics data, toxicogenomics and proteomics and so forth, became available, and the medical world had to adjust. So there was a problem, gigantic amounts of sequence data growing every day, and old biology and old medicine using terms like cell division or diabetes. How do you link the two bodies of data together? This problem was made worse because there was a need to link data about mouse genomics to human genomics. And the mice people and the human people, they divided the world of the organisms differently. So this problem was solved by a group of biologists working on so-called model organisms, such as mouse and fly and yeast, who realized they needed a common vocabulary to describe all the biological processes which go on inside mice and fish and rats and so on, and humans in the same way. So they created a vocabulary, and they called it the gene ontology. Now, why they chose the word gene ontology, that's a long story. In a way, it was a kind of joke, but it was incredibly successful, and it succeeded in transforming the way in which biologists dealt with data. I had the world's first Institute for Medical Ontology, and very quickly I became involved in this gene ontology world. And for one reason and another, they put me in charge of the logic of the gene ontology, which gave me a lot of influence in a discipline or a collection of disciplines, which was becoming itself more and more influential in transforming medicine. And on that basis, I acquired the ability to apply philosophy in a way which led people to be able to get jobs, which I guess is what we are talking about now.
Yes, that sounds intriguing, to say the least. Right. Well, maybe we can back up before we dive into the interesting topic that you're alluding to and situate ontology in the history of the discipline, because that's how it's normally thought about. So perhaps you could just speak to that and then fast forward to the present with these practical applications of ontology. So just a little context from your perspective?
Good. So from my perspective, everything starts with Aristotle. So Aristotle's table of categories is an excellent example of an ontology. And notice I say an ontology. So from the modern perspective, an ontology is an information artifact. It's created by a human being. So Aristotle created the first ontology. And he used various principles, so taxonomical principles. You can conceive of the ontology as organized like a tree, and Porphyrius is said to have conceived it explicitly in those terms, and commentaries on Aristotle after Porphyrius involve pictures of trees with substance at the very top, Plato and Aristotle at the very bottom.
I was going to say that's a perfect introduction, because that really mirrors this new realm in so many respects, right? The classification that we'll talk about today. And maybe we go there in terms of what is the modern market for philosophers here, because it is ontology, as you just traced the lineage. So maybe a brief description of this new realm, and then we can get into specifics about what industries and companies and so forth. But maybe an overview of what this looks like, of what different ontologies, as you know, look like today.
So maybe the most famous ontology, which I imagine a very large number of people watching this interview already have in their pocket, is the Siri ontology. So the Siri app in your iPhone is an ontology-driven app. It was designed by the first person to define the word ontology in the modern sense, an AI scientist by the name of Tom Gruber in Stanford. And Gruber was part of the first wave of computational ontology in Stanford in the 1970s. And they took the word ontology from Quine. They saw an ontology as a collection, hierarchically organized, expressed in predicate logic, of the terms which correspond, in Quine's case, to a science, and in the Stanford AI community case, terms used by people when they're exercising their common sense. The ontology created by Stanford was created to aid robotics. How can we make a robot have human common sense? The answer is that we formalize human common sense, and we give the formalization to the robot, and the robot will then have common sense. That failed, of course, but that was an idea which provoked a large amount of effort in building ontologies and software for building ontologies, which are a bit like word processors. And that's where I came in. In 2002 or so, the gene ontology, which had already been named an ontology, it was realized it needed to be formally structured in the way that they were doing with the naive ontologies they were building in Stanford using logic. So they put me in charge of the logic of the gene ontology. And then I became involved in creating more biological ontologies to work with the gene ontology. Now, there are various skills that you need to have in order to be a good ontologist. And many of those skills, including a knowledge of logic, are the skills which are required by philosophers.
Yeah, it's absolutely fascinating. So you talk about the medical world, but this also applies to other industries, right? So maybe you can just touch on other applications, industrial applications, defense applications. So this classification, codification really applies broadly, it seems to me, across private and public sectors.
Yeah.
Maybe just a little bit about that.
So I myself, for the first 10 years or so, was employed on NIH grants given to organizations who were building ontologies, using ontologies, trying to find value in ontologies for medical science. In around 2010, I was approached by the Department of Defense. They invited me to the Pentagon, and I gave a talk to a large audience of people working in Army intelligence. I told them how to build simple ontologies and why they should want to build simple ontologies in the same sort of way that the biologists were doing, but now the data was not sequence data, it was data about Afghanistan. And they had a certain impact. They followed through on some of my ideas, but there was nothing formal or serious. But over the time, more and more opportunities in defense and intelligence have arisen, and I could talk about those. But then I became interested in the idea of applying this to industrial engineering and industrial manufacturing. And one of the more promising current initiatives which I'm involved in is called the Industrial Ontologies Foundry, which is trying to create a suite of ontologies for industry. Now, those are the areas I know. That's
Right.
biology, military, and industry. But I know from my colleagues that there are many other areas where ontologists are being employed. And it's very easy for my students to get jobs. I could use more students because there is this growth in awareness. And that's something we haven't addressed yet, of the need for ontologies. Why do people need ontologies?
Right. And so are there companies that are looking for these people, like major technology firms or defense companies, so that if someone, had the skill set, they could find companies that are hiring?
So if you go to Google Jobs or to any of the other big job websites, then on a typical day, you will find of the order of between 30 to 50 jobs in which the word ontology is used, or ontologist. If you dig a bit deeper and you start looking for semantic technology, then you might find on any given day 100 jobs. Now, a number of those will be for Amazon. Some of them will be for Google, but then others will be for medical research centers, medical institutions, industrial bodies, banks, companies working on the information side of investing who want ontologies of businesses, for instance.
Right.
And I could go on. So there are many, varies from day to day.
And the skills and the kinds of tasks that you would perform, across this landscape, logic, semantics, things that you've raised, anything else that would provide more color on the responsibilities and activities if you were in ontology for Amazon, to take your example, just a brief example of what's the day-to-day look like if someone listening to this is saying, wow, I find this really interesting. What might I do every day?
Good. So I think for Amazon, and I don't know anybody who works for Amazon, but I think it's a good example. I think somebody who is a good philosopher probably doesn't need anything more than that, because the job will primarily be addressing new and interesting problems of classification. So new toys, new gadgets are invented. Where should they go in the Amazon ontology? And there is a big ontology that it doesn't run Amazon, but it runs behind Amazon, and it's what enables them to determine where to position particular new kinds of entities that are created and how to market them. As an ontologist working for Amazon, you're going to be talking to people engaged in marketing and so forth. I must say that for most ontology jobs, you're going to need to know more than just a philosopher would know.
Right.
First of all, you would need logic. We talked about that. You would need to have good skills, creative skills in logic. You'll get a job more easily if you have some computational skills.
Right.
And the computational skills involve use of the software that I mentioned earlier. So that the main open source software for ontology authoring is called Protege. And it came out of Stanford again. I have problems with Protege, but it is a piece of software that philosophy students find easy to learn. You can build ontologies with it. If you want to build ontologies with a certain kind of logical sophistication, then you need to have the corresponding logical sophistication and do work. Once you've done that work, you will appreciate what ontologies are as computer artifacts, because they're not just created for humans. Each term, each node in the ontology tree will have a human-centered natural language definition, but it will also have a formal definition, which may be in first-order logic, or it may be in some other language, formal language, which a computer can read. Gradually, you will learn about the computer ways of expressing ontology terms. And the more you invest in that side, the easier it is to get a job in the computational side of ontologies. I do not work on the computational side of ontologies, and many of my students who have jobs in the ontology world do not work on the computational side of ontologies, but they will work with other people who do work on the computational side of ontologies, since ontology arises in a world where there are computers.
But there's a path, right? There, for interested people that are listening to this, there would be a path to getting up to speed, and have the practical capacity to work at one of these companies or start at one of these companies, and then follow the lead of the company and understand what they're trying to do. So it's a tangible, of course. It sounds like, Barry, that these are high-paying jobs. I mean, just to put this into context, right? This is very important private sector work that's exploding. We'll talk about that in a minute, what it means, what technology means for the sector. But is that a fair assumption that as people hear you talk about this, that these are attractive jobs, shall I say, that would potentially be important and high-paying? Is that fair?
So somebody who is a well-qualified ontologist graduating with a PhD with an obvious application orientation, I know from experience, such a person can be hired with a starting salary of $150,000.
Okay.
Salaries are quite substantial.
Yeah, that's very helpful. So let me take a step back here, and we've talked a little bit about the roles, the possibilities, the industries, but kind of consistent with the series that this is a part of. You know, one thing that was brought to mind was, is this philosophy? What is philosophy in the modern world with technology and advancement and these sorts of roles? On the one hand, it sounds like computer science with classification, but you mentioned logic and semantics. And you've also spoken about how this involves multiple disciplines. So how would you, if you're hopefully people in the philosophical community are listening to this, how do you think about this? Is it the end of philosophy? Is it a sort of the most practical application, or it can be more computer science? Is it fluid? And there's a spectrum here, but it sounds like it's a good foundation. If I may philosophy, that is, if I may anticipate your answer.
So it's fluid and it is a spectrum. So I'll give you two examples of journals in the ontology world. One is called Applied Ontology, and it's a journal, as you can imagine, devoted to the application of ontology. It is quite deliberately and explicitly a journal which includes both philosophical contributions to philosophical ontology and contributions to what we might call domain ontology, which means ontology not in general, but ontology applied to medieval music. Or it's not a very good example, but you get the idea.
Yes.
A second journal that most people who work in logic and semantics have never heard of is called the Journal of Biomedical Semantics. Now, if I had encountered a journal with this title when I was learning logic as a student, I would have been somewhat shocked. How can biomedicine have anything to do with semantics? Well, in fact, it's a journal which is devoted to quite high-tech issues in ontology and related disciplines, but of relevance to biomedical informatics. So the problems raised by the Genome Project are still there. There are all kinds of ontological problems which still need to be addressed, and that journal addresses them. So I know from the experience of my students that many of them get good jobs working as ontologists because they have philosophy skills. Some of them came into philosophy because they had computing skills. They wanted to expand their orbit, and they very easily got a job as an ontologist because they had computer skills. Others went onto the job market with a bit of help from me and acquired computer skills on the job, and that is also a perfectly satisfactory way of approaching it.
Yeah, it's interesting, Barry, that technology in some respects, I think, enables this whole sphere, right? So the linkage between technology and philosophy is so direct here. And I'm assuming it's fair to say that the progression, the advancement of technology is only going to create more opportunities, right? The one thing I'd like to talk to you about, does that mean more specialization of these roles? But technology seems to be just obviously fundamental and a huge driver of the growth of these job opportunities.
Yeah, so the reason why there is a need for ontology is because when a company or a government agency or some discipline in a university starts to use computers, they immediately acquire a lot of data. And so they buy database technology. Right. And they build a database vocabulary, codes for their data. And they do it differently because they have a certain idea about how entities in their domain can be classified. But then a year later, they have to share their data with some other agency or company, and they find that they have no way of linking. And ontology solves that problem by giving you a way of linking from the start. And how it works is rather complicated, but that is why there is an ever-growing need of ontology, because too many people build too many databases.
So I think that was a good segue into artificial intelligence, because that will be a major factor in the advancement of technology. And in some ways, what you're referring to is processes or applications that enhance computer reasoning, right? It's harmonization, it's codification. So is AI the accelerant that one would surmise here in terms of the potential explosion of roles and jobs and possibilities around this, as computers play such a bigger role in society?
So this is a complicated story. So first of all, many people assumed that the job of the ontologist, by which I mean an ontology builder, will become defunct because the work of the ontology builder will obviously be done by an AI algorithm. You take all the literature about medieval music or whatever it is, and the AI system will use machine learning parsers to pick out all the general terms and use software to devise a hierarchy, and then you have your ontology. That never works.
Well, someone has to design the algorithm, right?
Well, but also you can't design an algorithm which can replace human ingenuity when it comes to ontology building, because every terminology is more complicated than you would think. It's not easy to create a hierarchy. So I know from experience, from the very start of the gene ontology, people were beginning to think about how they could use AI to replace the human beings who were maintaining it. Now, you can do more with AI now than you could 20 years ago, but you still can't replace human beings as ontology builders with AI systems. And I wish I could say something in detail about why that is, but I know that it is because I look at the results very regularly of AI-built ontologies and compare them with what I know can be achieved by human beings.
Well, in fairness, you wrote a book about this, I think it's fair to say, and we'll have another discussion about that touches on this in terms of why machines won't rule the world, a topic for another day. But I think that very much foreshadows that argument. But maybe just coming back to the jobs in general, if someone listens to this interview and is really curious about next steps, what would your advice be? How do they learn more? How do they build a career? Because I think it's fair to say, Barry, that some people will have no idea that this sphere exists. I certainly didn't. For instance, on the APA site, there's non-academic jobs, and you're never going to come across anything as interesting as this. So this might be brand new to people who think that they could perhaps change the trajectory of their career and position themselves. So what is your guidance to the people that are listening to this and hearing something brand new? How might they build a career here?
So if you go to my website, you'll see a link to a book, which is called Building Ontologies with Basic Formal Ontology. That is, I think, a good introduction to ontology. It's about building ontologies, which is what you need to know. It was written in such a way that I think philosophers can understand it. It's not a deeply technical book. It doesn't go into the technical details of protege definitions, for instance, although it does talk about profit. Read that book. If you are incentivized by the book, then contact me. That would be one possibility. I should mention two other things. Basic formal ontology was the top level, philosophy level ontology, which I developed in order to provide the logic for the gene ontology, if you like. And last year it was made an ISO standard. So ISO is the International Standards Organization. There are ISO standards for all kinds of things, plugs and sockets, for instance, which make plugs fit into the sockets all over the world. This was, we think, the first ISO standard for a piece of philosophy. And its design is to make databases fit into each other all over the world. That's a very rough account. And so the book is about building ontologies with basic formal ontology, and basic formal ontology is the subject matter of the ISO standards. It's ISO IEC 21838-2.
Gotcha. But I think the upshot for the people listening to this is that there are real companies, important companies, big companies in the private and the public sector, in medicine, industrial applications, defense, that are looking for people, and that there is a path, to build up a skill set where you could join one of these firms and obviously immerse and figure out what they're trying to accomplish, and use the way of thinking, the philosophical disposition, if you will, but logic, semantics, and other tools which you could learn to transition into something that sounds pretty exciting and modern, and probably is only going to get more interesting and bigger. So with that, let me just mention again that next week we'll have a discussion with your co-author about your book, Why Machines Can't Rule the World. And it very much is linked to, I think, what we talked about today, but we'll save that for another day. I just want to thank you so much for reaching out and scheduling this, and I hope people find it interesting. And who knows, Barry, you might get a lot of contacts after this. So thank you very much.
Oh, and thank you. You did a great job.
Thank you.